Hi, Assalamualaikum and good day to all students. For this video, we are going to cover for chapter 4, which is steam table and psychrometric chart. For the first part of this chapter, we are going to cover for steam table, whereby for the second part, we are going to cover for psychrometric chart. Psychrometric chart require its own exclusive video because the use of psychrometric chart is quite tricky and you need to have a good understanding for the use of psychrometric chart. Alright, so without further ado, now let's move on to the introduction for the steam table. For the steam table, you need to know what are the properties of the steam. So for the steam, it has three properties. So the first one is known as saturated liquid. Saturated liquid is whereby the amount of liquid water is having at the same amount with the vapor. In an enclosed container, liquid water is in equilibrium with its vapor. And the second properties is known as saturated vapor. Saturated vapor is also known as saturated steam, whereby all the water will vaporize at the boiling point of the liquid. The boiling point of the liquid depends on the type of liquid. For example, if let's say you are boiling a normal water, tap water for example, the boiling point is around 100 degrees Celsius, so the water will start to vaporize at 100 degrees C. But if let's say you add salt, then the boiling point will start to increase. It's no longer 100 degrees Celsius. Maybe it is at around 110 degrees Celsius. So it depends on the type of the liquid. Slight cooling at constant temperature, at constant pressure will result in condensation from the water vaporization. So the change in phase will cause a release of heat. So for this particular saturated vapor, there will be a heat transfer involved as well. And the third properties of the steam is known as superheated steam. Superheated steam is whereby the water vaporizes at a temperature higher than the boiling point. Meaning that if let's say you continue to heat the water above than 100 degrees Celsius, for example a normal tap water, then the water that starts to vaporize above than 100 degrees C is known as superheated steam. The steam contains more energy than what it is required to fully vaporize all the moisture, then it is known as superheated. With increasing the temperature of saturated vapor, it will produce superheated steam. Alright, then we move on to the saturated steam table. Steam table are tabulated values for the properties of saturated and superheated steam. Please refer to attachment 1 and attachment 2, whereby you are going to deal with the column that we have in the saturated steam table. For attachment 1, this one is meant for the saturated steam in degrees Celsius. If you look at the temperature here, okay, here the column of the temperature, the first column on your left hand side, the temperature is in degrees Celsius. Okay, and then the second column, this one is for the pressure. This pressure, it shows the relationship between pressure and the temperature for the water starts to boil. Okay, and then the third column is meant for the enthalpy. Okay, saturated vapor, whereby it is being subscripted with Hg. For this particular saturated vapor, it is being subscripted with Hg. G is meant for gas, so that's why it is the enthalpy. The short form used for the enthalpy is Hg. And then the following column for the latent heat here, this one is latent heat of evaporation. Okay, it is being denoted by HFG. Alright, HFG meaning that the difference between the enthalpy of saturated vapor, Hg, this one, the column of saturated vapor, Hg, minus by enthalpy of saturated liquid, HF. But in this attachment, we don't have the column for HF. So you need to calculate for the value of HF. So how are you going to calculate for the value of HF? It is being stated here, saturated liquid HF, F meaning fluid. Alright, so saturated liquid HF equivalent to the difference between saturated vapor Hg minus by latent heat HFG. So if let's say the question asks you to calculate for the saturated liquid by using this attachment, this steam table, then what you need to do is you need to subtract the value of saturated vapor Hg minus by latent heat. Okay, this third column minus by the fourth column. Okay, now we look at the example number 1. Okay, calculate the enthalpy for the following: saturated steam at 90 degrees Celsius, latent heat of evaporation at 90 degrees Celsius, and water at 90 degrees Celsius. Okay, this one is a very straightforward example whereby you need to answer the question by simply looking at the attachment number 1. So saturated steam at 90 degrees Celsius, this one is being denoted as Hg. Hg is over here, saturated vapor. Then you look at 90 degrees Celsius. By using your ruler, you need to use a ruler for the steam table. By using ruler at 90 degrees Celsius, then you will look the value of saturated steam, saturated vapor is at 2660 and the unit is kilojoule per kilogram. Alright. And then the second example, latent heat of evaporation at 90 degrees Celsius. This one is HFG. HFG is in the fourth column. So again, at 90 degrees Celsius, okay, you look at 90 degrees Celsius and what is the value for the latent heat? Latent heat is 2283. Okay, can you see that? Alright, and the unit is kilojoule per kilogram. This one is very straightforward question. Okay, and then water. So water, this one, it is referring to the saturated liquid. Okay, saturated liquid. So what you need to do is you need to subtract the value of Hg minus by HFG in order for you to get the value of saturated liquid HF. Okay, so what you need to do is 2660 minus by 2283, it is equivalent to 377. The unit is kilojoule per kilogram. Alright, so this one is very straightforward. And for attachment number 2, this one is the same thing. The first column on your left hand side, this one is meant for the temperature. And again, the second column is meant for the pressure. It shows the relationship between the pressure and the boiling point of the liquid. This one is the temperature. Boiling point will be the temperature of the liquid to start to boil. Okay, but then this particular temperature, the unit is in degrees Celsius. It's no longer in the temperature is in degree Fahrenheit, not in degrees Celsius. Okay, and then you have the column for the specific volume for saturated liquid, evaporation, as well as saturated vapor. These three column, one, two, three column, this one is not really going to be used in your part, in your chapter. Okay, we are interested for the last three of this column, enthalpy. Can you look at the word of enthalpy? Enthalpy, and the unit is BTU per pound. Okay, just now for the attachment 1, the unit is kilojoule per kilogram. But for the enthalpy of attachment 2, since this one is using British unit, the enthalpy unit is BTU per pound. And can you see here, the first column under the enthalpy, we have saturated liquid, HF, alright? And then we have the evaporation, HFG, latent heat of evaporation, HFG, followed by saturated vapor, Hg. So every single properties of steams are available here. Okay, so you do not need to do subtraction as what you did in chapter in attachment number 1. Alright, so let's take a look for the example by using this attachment 2. Attachment 2, calculate the enthalpy for the following: saturated steam at 135 degree Fahrenheit, latent heat of evaporation at 135 degree Fahrenheit, as well as water at 135 degree Fahrenheit. Again, this one is very straightforward. So you use attachment number 2, this particular steam table. So you look for 135. Okay, so what is the value of 135? Okay, please use your own ruler. Don't use your finger, because sometimes during my previous experience, the students, they tend to use, when the student use their finger, then when they scroll from one column to another column, they will get different value, because probably their finger starts to move to the wrong side. Okay, so please use your ruler. So you need to have a ruler and then point out at 135 degree Fahrenheit. And when you place the ruler, please place it properly as well. Okay, so the value are there at 135. It's very straightforward here. Okay, so you have the saturated steam Hg at 135 is 119.9 BTU per pound. And then you have latent heat of evaporation Hg at 1016.9 BTU per pound, as well as the water. You can get straightforward from the table, steam table, 102.95. Or if you got extra time and you want to do simple subtraction, then it's alright. You will get almost similar answer. Okay, and then we move on to the following example. For the following example, you can see that the temperature is 129.44 degrees Celsius. Okay, first, what you need to do is you need to check the value of temperature, whether this value of temperature is available in attachment number 1 or it is not available. Alright, so let's move back to attachment number 1. If you see attachment number 1, the temperature range starting from 0 until 125 degrees Celsius only. Okay, it stops here at 125 degrees Celsius. So, can you get the value of the steam properties by using attachment number 1? Okay, let's take a look again at the example number 3. The temperature is 129. It already exceeds the range of temperature in attachment number 1. Okay, so what you need to do is 129 is beyond the limit from attachment number 1. So what you need to do is you need to use attachment number 2. You need to use steam table attachment 2, not attachment 1. Okay, but then attachment 2 is using the temperature unit in degree Fahrenheit. So what is the thing that you need to do? The first thing that you need to do is you need to convert the temperature from degree Celsius to degree Fahrenheit. Okay, and basically this particular equation will be given to you, so you do not need to memorize, but if you memorize, it's alright as well, as long as you memorize the correct equation. Don't use different value. Alright, so first thing first, what you need to do is you need to convert the temperature from degree Celsius to degree Fahrenheit. Okay, so now when we convert the temperature, we will get at 265 degree Fahrenheit. Okay, now let's check the temperature in attachment number 2. Do we have 265 degree Fahrenheit? Okay, we have it here. Can you see at 265? It's over here. Okay, this one is very clear cut as well because the temperature is available, so the value for the enthalpy is available as well. Okay, so the value for the saturated steam Hg at 265 degree Fahrenheit is 1169 BTU per pound, whereby the latent heat of evaporation at 265 degree Fahrenheit HFG is 935.2 BTU per pound, and saturated liquid water, this one it refers to saturated liquid HF. Okay, fluid, F is a fluid. So the value for HF from the table, the steam table attachment 2 is 233.85 BTU per pound. Don't forget your unit because this unit will indicate which attachment that you are using. Clear? Alright. So if let's say you got extra time and you want to check whether your value for the water, the saturated liquid is correct or incorrect, then you can do simple subtraction, but it is not necessary for you to do it. You can just get the value directly from the steam table. Okay, then we move on to the superheated steam table. Superheated meaning that the liquid boils above than the boiling point of the liquid. So both temperature and absolute pressure must be specified to accurately determine the specific volume V, whereby the specific volume is in feet cubic per pound, and enthalpy H. Alright, H is referring to enthalpy, and the unit for the enthalpy is BTU per pound for superheated steam. Okay, superheated steam table, again, this one, the unit for superheated steam table is in British unit, because you can see that the unit is given in BTU per pound, the volume is in feet cubic per pound. Okay, now we move on to attachment 3, whereby attachment 3 is specifically meant for superheated steam table. Temperature is given in Fahrenheit, the pressure is given in PSI, specific volume is given in feet cubic per pound, whereby the enthalpy is in BTU per pound. Alright, so this is the attachment 3, whereby you have 3 sets of column, 3 sets of table, 1, the middle table 2, and then the bottom table 3. Okay, so you have 3 tables, 1, 2, 3. Now please look at the bottom part of this table. Okay, V, the short form for V is meant for specific volume. The unit for V is feet cubic per pound. And then we have H. H, this one referring to the enthalpy. The unit is BTU per pound. So where does this H and V are being used? They are being used in each column for different pressure. Okay, for example, this one 25 psi, and under 25 psi we have 2 columns, V and H. Okay, can you see that? V is meant for volume, V volume, H enthalpy. So we are interested to calculate the value for the enthalpy, not volume. And please check that the unit for the enthalpy already given here is BTU per pound, not feet cubic per pound. Okay, so please make sure that you are clear there. The 3 tables here, this one is meant for different pressure. Okay, from the low pressure to higher pressure. Right, we have from 1 psi, and then we have 15 psi at the center of the table, and then 30 psi up until 35 psi for the last table. Alright, we move on to the example. Example 4, calculate the enthalpy for the following: superheated steam at 10 psi and 250 degree Fahrenheit, different pressure, different temperature. Superheated steam at 15 psi and 300 degree Fahrenheit. Superheated steam at 25 psi and 450 degree Fahrenheit. So what you need to do is you need to check your attachment 3. Okay, so for attachment 3, enthalpy for superheated steam at 10 psi and 250 degree Fahrenheit. Okay, now you need to look for the table that containing 10 psi. Okay, so it is at the top part of the table, 10 psi. Okay, and then the temperature is 250 degree Fahrenheit. Okay, on your left hand side, the column are meant for the temperature. The temperature is in degree Fahrenheit. Okay, so look for 250 degree Fahrenheit. 250 degree Fahrenheit, and 10 psi. Okay, but which value that you are going to take? Is it V or H? It's supposed to be H. Okay, so from the table it is 1170.2 BTU per pound. Okay, and then the second one, enthalpy for superheated steam at 15 psi and 300 degree Fahrenheit. Again, refer back to your attachment 3. This one is 15 psi. Look for 15 psi. This one is 15 psi. And the temperature is at 300 degree Fahrenheit. 300. Okay, look for 300. It start off with 250, then followed by 300. So 300, and we have V and we have H. We are interested with H. Okay, the value for H is 1192.5 BTU per pound. Okay, so can you do that? Do you manage to find the value? Alright, now let's move on for the enthalpy. Superheated steam at 25 psi and 450 degree Fahrenheit. Alright, 25 psi, 25 is the last table, the bottom one, 25 psi, and the temperature is at 450. Okay, 450 degree Fahrenheit, 450. 450, the temperature 450, then we move on to the enthalpy is 1262.5. Okay, and don't forget to put in the unit. It's supposed to be in BTU per pound. Okay, interpolation. Interpolation. The entries, the value entries in the table are not close enough to cover all conditions, meaning that not all values are going to be given in the table. Okay, certain value of temperature are not going to be there, are not going to be in the table. So you need to find on your own how to get the value of the enthalpy when you are being given different set of temperature to calculate for the enthalpy. Okay, so the first one, calculate the enthalpy for saturated steam at 97 degrees Celsius. Calculate the enthalpy for water at 102 degrees Celsius. Alright, so the first thing first, please check the temperature value. Okay, the temperature value here is 97 degrees Celsius. The temperature value here is 102 degrees Celsius. So can you use attachment 1? Can you use attachment 2? So which attachment of the steam table that you are going to use? Okay, by looking at this temperature, I confidently say that you can use steam table from attachment number 1, because if you remember, the maximum temperature provided in steam table number 1 is up until 125 degrees Celsius. Okay, so for both questions, you can use attachment number 1. Okay, so 97 degrees Celsius, it is located in between 90 and 100. Okay, the temperature difference between 90 and 100 is 10 degrees Celsius. Am I right? Right? And then look for the temperature for 102 degrees Celsius. So the value that we can find in the steam table is 100 degrees Celsius and 105 degrees Celsius. So the temperature of 102 degrees Celsius is located in between 100 and 105. Alright? Okay, and then we have the value for the pressure at 90 degrees Celsius. We have the value for the enthalpy at 90 degrees Celsius. We have the value for latent heat at 90 degrees Celsius. Alright, for 100 is the same thing. We have the value for the enthalpy as well as the latent heat at 100 degrees Celsius. And then at 105, we have the value as well for the enthalpy and for the latent heat. This value I get from the attachment number 1. Okay, steam table from attachment number 1. If you are not convinced, then you can check on your own whether this value are correct or incorrect. Okay, So now, since 97 is located in between 90 and 100, and 102 degrees Celsius is located in between 100 and 105 degrees Celsius, so you need to do interpolation. Okay, you need to do some simple subtraction and division. Okay, so now let's move on to the example so that you have a better understanding. Okay, this one, calculate the enthalpy. So, okay, the answer, calculate the enthalpy. Alright, the steam, Hg, saturated steam is Hg. Hg at 90 degrees Celsius. Okay, where is this? Okay, Hg at 90 degrees Celsius is 2660 kilojoule per kilogram. Whereby Hg at 100 degrees Celsius, this one is 2676 kilojoule per kilogram. Where do I get these values? They are from the steam table of attachment 1. Okay, so now look at your left hand side, we have the temperatures. Your right hand side, this one is the value for the enthalpy. Okay, so for left hand side, we have 100 degrees Celsius and we have 90 degrees Celsius. So what is the value of this temperature difference? 100 minus by 90. What is the value of temperature difference that you get? 100 minus by 90, you should be able to get 10 degrees Celsius. Whereby for delta H, you need to do subtraction. 2676 minus by 2660. So for the delta H, you will get 16 kilojoule per kilogram. Don't forget your unit, kilojoule per kilogram, this one representing for the enthalpy. Degrees Celsius representing for the temperature. Okay, so by having the temperature difference as well as the enthalpy difference, you can know that for every 1 degree Celsius, it contains enthalpy at 1.6 kilojoule per kilogram. How do you get this value? 16 kilojoule per kilogram divide by 10 degrees Celsius. Okay, 16 divide by 10, you will get 1.6. So for every 1 degree Celsius, the increment of the enthalpy is 1.6 kilojoule per kilogram. Can you get what I said just now? For every increment of 1 degree Celsius, the enthalpy will increase by 1.6 kilojoule per kilogram. So, the temperature given from the question is 97 degrees Celsius. And the value that we have from the steam table in attachment 1 is 90 degrees Celsius. Question 97. In the steam table, 90. What is the temperature difference between 97 and 90 degrees? 97 minus by 90, you will get 7 degrees Celsius. So for 1 degree Celsius, you will have 1.6 kilojoule per kilogram. But what happened when the temperature is increased for another 7 degrees Celsius? So that's why you will need to multiply 1.6 kilojoule per kilogram. You need to multiply by 7. This particular value of 7 coming from the temperature difference between 97 and 90 degrees Celsius. Okay, and then since we are referring to 90 degrees Celsius, get the value of enthalpy at 90 degrees Celsius over here and bring it down to 2660 plus with the increment of the enthalpy for 7 degrees Celsius. Okay, so calculate the value 1.6 times by 7. What is the value? Then plus with the value of 2660. And you should be able to get this value to 671.2 kilojoule per kilogram for Hg at 97 degrees Celsius. Alright, can you get it? Okay, if you don't get it, can you please post your comment either in the Google Classroom or in this video? Okay, and then example 2 is whereby you need to calculate the enthalpy of water at 102 degrees Celsius. For 102 degrees Celsius, the same thing goes. Okay, and again this one we are going to use a steam table from attachment number 1. 102 degrees Celsius is located in between 100 degrees Celsius and 105 degrees Celsius. So what you need to do is you need to find first the value for HF. Okay, the value for HF. Enthalpy for water or enthalpy for fluid, HF. Enthalpy for fluid, how do you calculate enthalpy of fluid? Is whereby saturated vapor Hg minus by latent heat of evaporation HFG. Okay, saturated vapor at 100 degrees Celsius is 2676. Latent heat of evaporation HFG at 100 degrees Celsius is 2257. So you will get the value of HF at 419 kilojoule per kilogram. Okay, and then move on to HF at 105 degrees Celsius. Why I need to calculate the HF at 100 degrees Celsius and 105 degrees Celsius? Because you need to refer again to the question whereby you need to calculate for the enthalpy of water at 102 degrees Celsius. Okay, so again, the same equation is being used. So saturated vapor Hg at 105 degrees Celsius is 2684 minus by 2244 is the value of latent heat of evaporation at 105 degrees Celsius. So you should be able to get the value of 440 kilojoule per kilogram. Okay, clear? Alright, now so this one is HF at 100 degrees Celsius is 419. From what you have calculated here, make sure you calculate this value properly. Okay, 419 kilojoule per kilogram is HF at 100 degrees Celsius and HF at 105 degrees Celsius is 440 kilojoule per kilogram. So on your left hand side, you have your temperature. Calculate the temperature difference. The temperature difference is 5 degrees Celsius. Alright, and then on your right hand side, you have the value for the enthalpy for the respective temperature. Okay, calculate the calculate the enthalpy difference. The enthalpy difference is 21 kilojoule per kilogram. Alright, so for 1 degree Celsius, for the increment of 1 degree Celsius, what is the value of the HF? So what you need to do is 21 kilojoule per kilogram, you divide by 5. So you will get 4.2 kilojoule per kilogram. Meaning that for every increment of 1 degree Celsius, the enthalpy will increase by 4.2 kilojoule per kilogram. Just now, this one is the temperature difference, 5 degrees Celsius. So 5 degrees Celsius, the enthalpy increased by 21 kilojoule per kilogram. Got it? Okay. So now you can calculate the HF at 102 degrees Celsius, whereby 419, this one referring to the enthalpy of 100 degrees Celsius. We are referring back to 100 degrees Celsius. Okay. And then from there, you need to plus with 4.2 times by 2. Okay, where does this value 2 coming from? It is the temperature difference between 100 degrees Celsius and 102 degrees Celsius. Okay, so you should be able to get the value of 427.4 kilojoule per kilogram. Alright, so I guess we stop here first. Then we are going to continue in next video for the following example for the use of superheated steam table where you need to do interpolation. But basically the principle is the same thing. The principle are the same thing. So please try on your own how to do the calculation, the interpolation calculation. And then in your tutorial also you can try to do your tutorial. Alright, so until we meet again in next video, please do your exercise and then please fill up the attendance form. Okay, thank you.